can you pass control information alongside with your data when using a JOX channel? Let's find out. In the last video, we briefly introduced JOX, what it is, how can you use it, and where it's coming from. Let's take a look at some use cases where the unique features of JOX actually make a difference. But first, let's start with a brief recap of what JOX actually is. JOX is a Java library designed to work with virtual threads, which are available from Java 21 onwards. JOX defines a queue-like data structure, a channel. You can create a channel with a given capacity, so it can be unbuffered, buffered, or unlimited. You can send elements to a channel or receive elements from a channel. Sending will block if no more capacity is available. Same with receiving, it will block if there are no more elements to receive. JOX also offers some features which make it distinct from a queue. First of all, you can complete a channel, saying that no more elements will be sent. Secondly, you can say that there has been an error and that processing should stop. Finally, JOX supports the select operation. You can pass in a list of clauses from which exactly one will be selected and completed. For example, you can say that you want to receive a value from one of 3 channels. If this sounds familiar, it should, because it's exactly the design that's present in Go. Our use case is going to be receiving prices for a given stock ticker. In a high-frequency trading scenario, this is probably done using a specialized protocol, but for our demo purposes, a WebSocket is perfectly fine. So let's take a look at the code. So first of all, we've got a method which fakes connecting to WebSocket endpoint, given a ticker symbol. So we store this in the class. Then we also have a receive method, which is supposed to read data from the WebSocket in a blocking way and return it to the user. So this method performs I/O. So it might throw an I/O exception. It might also throw an exception when the WebSocket is closed by the server. So in the implementation, again, we've got some fake implementation here. So what we do is first we randomize our behavior, and if it turns out to be 0, we simulate closing of the WebSocket by the server. So this scenario corresponds to a case where the stock market is closed and there will be no more ticker updates, at least for some time. Then we've got a scenario where the result was 1. Then we simulate a network error, right? A broken connection, so we throw in an I/O exception. And finally, we've got the happy case where we actually return the price. So the price is always going to be between 2 and 19 of some imaginary currency. Okay, so that's our receive method. So let's take a look how we can combine this fake WebSocket with a JOX channel. So first of all, we will take a look at a very simple use case where we've got a single channel to which we would like to feed the WebSocket data. Of course, the question is, why would we want to do that? And the answer is that it's often much more convenient to work with a stream-like data structure than with an imperative WebSocket interface, right? We can call the receive and the send method on a real WebSocket, and that's a very imperative way of interacting with the WebSockets, and that's completely fine. It's very often all that you need, but sometimes it's more convenient to have a stream of updates, right? We can then, for example, subscribe to the updates, persist them in the database, transform them somehow, run some side effects for each element received, and so on and so on. So here we have a method using which we can feed a given WebSocket to a channel, right? So we have a WebSocket from which we want to receive data, and we have a channel to which we want to forward all the data received from the WebSocket. So the base case is very simple. In a loop, what we do is we receive from the WebSocket and we send data to the channel. And in the happy case, that works perfectly fine, but then we also have the cases when things go wrong. So the first thing that might go wrong is there might be a network error. So if there's an I/O exception happening, like a broken connection, what we do is we propagate the error to the channel, right? We inform the channel that an error has occurred. Alternatively, what might happen is the WebSocket might be closed, right? If you remember correctly, we had in our fake WebSocket, we could either simulate a broken connection, simulate no more data, or just simulate that some data has been received. So that's the case where the WebSocket was closed by the server, indicating that no more ticker updates will come at least in this trading day. And so then what we say is that no more data will be received on the channel, so we use the done method on the channel. So that's how we can transform both the data. So here we transfer the data from the WebSocket to the channel, and here we transfer the control information, right? The control information is either that there has been an error or that no more data will be arriving. So once we have this channel, we can do all sorts of things. For the purpose of the demo, we will just dump the channel content to the standard output. What is worth noting is that now the channel contains the entire information about the WebSocket, right? If the WebSocket connection breaks, the channel will actually contain information that there has been an error, right? So this channel represents both the data and the control information in one abstraction. So here we have some example code using which we can consume our channel just to see if it works. So very briefly, let's take a look at what this code actually does. So what we do is we receive from the channel, we use the receive or closed. So this method either returns a string, which is the data component that has been an element that has been put on the channel, or it returns information that the channel has been closed because there has been an error or that there are no more elements. So if the channel is done, we simply log some information so that we can see on the screen what's happening. If there's an error, we also log that information, and we break the loop, so the consume loop actually ends because there's nothing more to consume. If some data has been received, we again log this information. We then pretend to do some work with that, maybe running an algorithm, deciding whether we should actually buy or sell the stock, and then we receive subsequent data from the channel. So what's important? There's an important distinction between a channel being done and a channel being in an error. So let's actually go back here. So if we signal that a channel that there has been an error, any elements that are still pending in the channel and not received will be removed from the channel, right? So it's like a short-circuiting operation. Now, if the channel is done, any elements that are on the channel that are still pending to be received will be available for receiving after done is called. So after a done is called, you can no longer send more elements, but you can still receive the elements that have been sent before. With an error, it's like a short circuit. Everything is stopped. Okay, so that's our consumer, and here we've got just a simple implementation of a method which connects. Creates the WebSocket, so fakes a connection to a WebSocket, creates a channel to which we want to feed the WebSocket. Then we start a background thread because these are blocking operations, so we cannot just call the method which pipes the WebSocket to the channel. We have to do it in the background, so we start a virtual thread which pipes the WebSocket to the channel. And on the main thread we then consume it, and we can see that it actually works. So you can see that it so happened that we only received a single element and then there has been an error. So if we rerun this, you can see that now the WebSocket, we have received 2 elements and then the WebSocket has been completed. So we can try it once again. Maybe it will run for a bit longer. So the WebSocket is done, but we are still receiving the elements that have been sent before. So at some point we'll actually receive all elements that have been buffered, and now the channel is done. You can see that here we create a channel with a capacity of 16, which means that the fake WebSocket will enqueue up to 16 stock tickers before blocking on the send operation. Right, the send that is blocking here is over here, right? So this send will block when the channel is full. And actually here we have a slower consumer and a faster producer, right? Because the fake WebSocket can produce elements on demand, and the consumer is slower because it's sleeping. So what will happen is the buffer will fill up and then we will slowly consume. And once we consume, more elements will be produced. So in this example, what we have seen is how you can combine data and control information in a single channel. But that's quite useful, but it's not always possible to do it that way. And there's another scenario where you might actually want to separate the data and control channels. And that's what we will do in our second demo. So in our second demo, let's say we have a couple of WebSockets corresponding to different stock tickers. And we want to feed the prices of each of these tickers to a single prices channel, right? So we receive data from multiple stock tickers and we feed the data to a single prices channel. So now we cannot really use the control information or we cannot feed the control information of a single WebSocket to this channel over here, right? Because if there's an error on a single WebSocket, we don't want to break or to finish this whole channel, right? So what we want to do is we actually need to have a separate control channel where any control information, so if there's an error in any of these WebSockets, or if some of these WebSockets complete, we want to pass this information to this separate channel. And then the consumer needs to receive from both the control and prices channel and do the appropriate thing. So if it receives a price update, it should probably, run the buy-sell algorithm. If it receives information that the WebSocket died because there has been an exception, maybe it should restart the WebSocket or something like that. So let's take a look at how we can implement this scenario. So first of all, we need some data structure to represent the control information that we want to store on this channel, and we will do it using a sealed interface as over here. So we've got a WebSocket event, and the event is that either the WebSocket errored out, so there has been an exception like a connection error, or that the ticker is done, so there will be no more price updates for a given symbol. Okay, so now once again we have a very similar method as before. We have a method which feeds what is received from the given WebSocket to the prices channel, right? But we also, because now we want to actually separate the control information, we also have a separate channel to which we will send all the control events. So what we will do is we will call this method with different WebSockets, right? But with the same prices and control channels, because we want to combine the data coming from multiple WebSockets into a single prices channel. But as far as this method is concerned, we only have one WebSocket, one prices channel, and one control channel. So again, what we do in the very basic, in the happy path, what we do is we receive receive data from the WebSocket. So again, this might be blocking in theory. In our fake implementation, it will just randomize the next message to receive, and it sends things over to the prices channel. Now, of course, we need to add some error handling, right? So if there is a connection error on the WebSocket, what we do is we send information on the control channel, right? So the loop here ends because the exception is propagated outside of the loop, and we send information over on the control channel. In a similar way, if a given WebSocket became closed because there will be no more price updates, we send information that the ticker is done for the day. And so that's our method to transfer data from the WebSocket to the prices and the control channel. So now let's see how we can actually consume that information. So here we've got a simple consumer. So what the consumer does, what's the idea here, right? The idea here is that we want to receive information from the prices channel, which holds the data. Basing on that, we want to make some decisions, buy, sell, and so on. But if there is some control event, some WebSocket died because of connection error, we want to restart it. And actually what we want to do is for the control information have priority over the prices information, right? Because maybe the prices channel has a large backlog of information to process because there's a lot of stock information which we haven't yet processed. But we don't want, and we don't want to wait with processing the control events only after all the prices have been consumed. So we want to give priority to receiving data from the control channel, right? And only if there are no control events, we want to actually receive the next price updates. So you may think of it as a priority queue. However, in a priority queue, it's the producer that decides what's the priority of the data, right? At the time of producing, we have to specify what is the priority of the element that we are putting on the queue. So here, the priority is consumer driven, right? It's the consumer who decides which channel and which elements actually have priority. So what we can use here is we can use the select method. So as I mentioned in the beginning, this mechanism is inspired by Go channels. And what it does is it takes a couple of clauses. This can be either a clause specifying that we want to receive data from a channel or that we want to send data to a channel. So we get a couple of clauses, and select selects exactly one clause to complete, and the others will be discarded, right? So here we say we want to select exactly one element, either from the control channel or from the prices channel. Moreover, if there are multiple elements, so if multiple clauses could be completed, the ones that appear first have priority. So the control clause will have priority. So whenever there is data on the control channel, it will be received before data from the prices channel, right? So what this returns is it returns either a WebSocket event or it receives a string which is a price. So that's what our switch case here over says. So if we receive a price update, again, we just log information and pretend we are doing something smart for a second. If the WebSocket is done, well, there's no more data. What can we do about it? We will just let the user know. If there was an error, we will actually try to restart the ticker. So we start a background thread which will establish a new WebSocket for the given ticker symbol and feed the information to the prices and control channels. We also need a default case because string and TickerWebSocket don't have a common parent other than object. So it's not possible, but to make the code compile, we actually need to include that. But the important thing here is that we've got the select method, which allows us to prioritize from which channel we want to receive information and which guarantees that exactly one clause will be completed. So even if there's data on both of these channels, right, only one element will only be will only be received from the channel, and the other elements will wait for the turn. Okay, so our demo is almost complete, and we can also take a look at the start ticker method, which we are using when we restart a WebSocket. So what we are doing here is we are establishing a connection to our WebSocket ticker, and what we do is we start a background thread which propagates the data from the WebSocket to these two channels. As a demo, we have a very simple command line application. So at the very start, we create our prices channel with a low capacity because we don't want to buffer too much. We also create the control channel. then we start a background thread which will consume, so it will actually do the processing of the received prices and of the received control information. So this also needs to be done in the background. And in the main thread, what we do is we read from the start.input. And if the command received from the start.input is to subscribe to the given stock ticker, what we do is we start that ticker. So we establish a WebSocket and we say that the content, that whatever is received from the WebSocket should be forwarded to the prices and control channels. Okay, so let's try running that. So at first nothing happens, right? Because we haven't subscribed to anything. We can now subscribe to CD projekt, and you can see that the information is being received. At some point, probably the WebSocket will either complete or there will be an exception. So we will be able to see how it behaves. We can also subscribe to another stock ticker like Apple. So here a WebSocket is done. So the CD projekt is done and it's not restarting. So now we are only, so we have received all the remaining elements for the CD projekt stock ticker, and now we are only receiving Apple stocks. So once again, we didn't see an error yet, but it might still happen. Let's simulate us subscribing to a stock ticker XYZ, an imaginary company, I guess. I don't know, maybe it exists. At some point we should see stock tickers from XYZ coming in as well. Yes, and we are very lucky, we didn't yet randomize an error. At some point it will happen, and the Apple stock completed. At some point XYZ will also either complete or error out. Both are errored out now, so we can now subscribe to CD projekt once again. No errors, but if there was an error, the stock ticker would restart. Okay, so that's all that I had for this demo. You can find the code that we've been looking at here on GitHub. I will put the link in the description. Oh, there's an error, right? So we got lucky finally, and you can see that this stock ticker is restarting just as our logic specified, and we are still receiving data. So yeah, so the link for the code will be in the description. The JOX project is open source. It's on GitHub. It's Apache 2 license. So if you like it, please take a look. Start the repository if you think it's interesting. And I hope to see you next time. Thank you very much.